Basically, when we are studying the signals and system, I think you all people are coming across that we have two different type of signal. One is the analog signal, and second one is digital signal. So these kind of signals, we normally use when we are studying the communication system. Whether you are studying the digital communication system or analog communication system, then these things we used. But this subject, when we are studying these signals and system, we are generally discussing two very important types of signal. One is called the continuous signal, and another signal is discrete type signal. Another signal is discrete type signal. When we started studying this subject, signals and system, we basically discuss these two types of signal. We will only discuss these two types of signal. But when you study the communication system, two different types of signal is analog kind of a signal or the digital signal. So in this semester, I am going to taught the course signals and system, where we generally discuss the continuous type of signal and discrete type of signal, and how a signal can be represented in various forms. So today our lecture will be focused on different types of representation of the signals. So first we will try to understand what is this continuous signal and this discrete signal. So basically, whenever we have a signal, from the engineering point of view, from the engineering applications, we always try to represent every signal in the form of mathematical equation. We always try to represent the signal in the form of mathematical equation. And further, this mathematical equation can be applied on algorithms. So suppose if I am taking an example of a signal, I am taking an example of a sinusoidal signal. If I am taking an example of a sinusoidal signal, so you know that the sinusoidal signal is something like this way. Now, if I ask you to represent this signal in the form of a mathematical equation, then how you will represent it? So I can represent, this is my x-axis and this is my y-axis. This is my amplitude and this is my time domain. So I can represent this signal as x of t equal to sine omega t. This way we can represent the signal, and I can also write this signal in the form of a sine omega t, where a is the amplitude of the signal at each interval of the time. And you know that this omega is equal to nothing but 2 pi by t, and this can be written as 2 pi f, where f is the frequency of the signal. So this way, this sinusoidal signal can be represented in the mathematical form.